Let's see code. Number, okay, I haven't done this. Number of steps to reduce a number in binary representation to 1. Given a binary representation of an integer as a string s, return the number of steps to reduce it to 1 under the following rules. It is guaranteed that you can always reach 1 for all test cases. We just have to keep following these rules until it is done. How big can the number get? So s.length is up to 500, so I can't fit that within the integer. That's the main problem, not because it will take too long. So I have to figure out how it works in binary instead. Adding 1 is simple enough, and checking if it's odd is also simple. You just have to check if the rightmost digit is a 0 or 1. If it's a 0, it's even. If it's a 1, it's odd. When I divide by 2, let's say I have value 8. This is 8. And divide by 2, I get 4. And 4 is this. And that's 2. This is 4. What if I have 10? If I have 10 and I divide by 2, I get 5. So I get 4 and 1. Kind of looks like it just shifts across by 1. Yeah, that actually makes sense. When I move a digit 1 to the left, I'm doubling it. If I'm moving it down, I'm dividing it by 2. You know what I could do? I could have a deque that can check what the last character is, and also pop from the front and the back in constant time. And when I want to divide by 2, I remove a 0 from the right end and add a 0 to the left end. But then I also need an operation that checks whether the current number is a 1. You have 500 zeros and 1s. It will take around log n time to actually figure out how many steps. But to check whether it's a 1 every single time, oh wait a sec. Whenever I'm dividing by 2, I'm guaranteed that the leftmost digit becomes a 0. And so I can actually just ignore that, like so. Now I know that this is odd because the rightmost digit is 1. And then I could add 1 to that, which will give me 1, 1, 0. Actually, the operation of adding 1 can actually take up to O of n. So I actually don't need a deque, so I can, because I'm never going to add to the left end anyways. Or am I? Will there ever be a case where I have full 1s and I add a 1? Actually, there will be. Like in the very first case, if it's all 1s and I add a 1 to make it even, this will become 1, 0, 0, 0. So let's make a function that divides the binary string by 2. It's a void function that takes in a vector called s, and all it actually needs to do is to do s.popback. Now I need a function that add 1. Let's just call it add 1. What do I do with add 1? Oh yes, we wanted to use a deque, right? So if I find the first 0 closest to the right end, so I want to increment from I equal to s.size minus 1, I greater than equal to 0, minus I. In fact, I probably want to keep track of what I is, so let's do size minus 1 here. If si is equal to a 0, then break. If I is greater than equal to 0, I want to actually just change what s of I is to be equal to 1, so that will add a 1, else I need to do s.pushFront, I think that's the thing, pushFront 1. Let's also make another function called is1. We could just return s.size equal to 1. Cool. And then we just need to have a while loop, but true. And before I do that, let's put everything in a deque. I wonder if I can just do this s.begin, s.end. If is 1, d, break. So I want the answer to start off at 0 steps, and then if it's a 1, I break, and then I return the answer. That will handle the case where it's just a 1 passed in. Let's also have a function is odd, so return s.back is equal to a 1. If is odd, add 1. Else it's even, so half it. This should return a boolean. This should return a boolean as well. Oh wait a second. I just realized that my deque is shouldn't be an integer, it should be chars. No, I don't think that makes a difference. It just uses less space. Oh wow. Oh, I think my logic for adding a 1 didn't work, because when I add a 1, this becomes 0. And add one little thing, else s of I is equal to 0. Oh, this should be equals 0. And I forgot to actually plus the answer. Good thing about this example is I can just do something random and it'll probably work. Cool. Let's submit that. Nice. What's the time complexity of this? This function add1 could take up to 500. These operations, the number of steps is order of log n. Cool, thanks for watching. Like and subscribe, and keep eating the code. I'll see you in the next one.